Alright guys, so today we're going to talk about angles, arcs, and chords within circles. Okay, so don't forget those vocabulary words that we learned the other day. Alright, so here we go. So now we have the sum of the central angles. Okay, first of all, a central angle is an angle that is at the center of your circle. So for example, okay, we've got this angle right here, which would be a central angle because it comes from the center of the circle. So if I wanted to add them all together, so the sum of the central angles, so angle 1 plus angle 2 plus angle 3 will add up to 360 because all the way around they make a circle. So we have three different kinds of arcs. We have minor arcs, we have major arcs, and we have semicircles. So a minor arc is an arc that is less than 180 degrees. So for example, okay, so anyway, we've got minor arcs, major arcs, and semicircles. Okay, so an arc that's less than 180 degrees is going to be less than half the circle. So for example, from A to C, this would be arc AC, and you have to put the arc symbol over it or else it's not an arc. Okay, the measure of the central angle is equal to the measure of the central angle. So the measure of the arc is equal to the measure of the central angle. So if the angle measure is 110, then the arc measure is also 110 degrees. Okay. Now, when you're naming a minor arc, you will use two letters, and they are the two of where you start and where you end. Now, a major arc is greater than 180 degrees, and you will use three letters to name it. The first letter is where you start. The second letter tells you the direction to go, so I need to go around to F. And then the third letter tells you where to stop. So you have your starting, your direction, and your stopping. So now, if this angle right here is 60 degrees, and there's 360 in the entire circle. So if I have 360 degrees in the entire circle, this little part right here is 60, so I would subtract it, and I would find out that it was 300 degrees. So from this point here, so from right here, all the way around to right here is 300 degrees. Well, since that's 300 degrees, then this arc is also 300 degrees. So the measure of arc DEF, I'm sorry, DFE, so the measure of arc DFE is 300 degrees. Notice it is greater than 180 degrees, so that means it's bigger than half the circle. Then you have your semicircle. Well, the semicircle is just that. It's half the circle, and it is equal to 180. So you find your diameter, and you have two semicircles. You have semicircle J, K, L, where you start, where you end, and the direction. And then you also have semicircle J, M, L. So you have two different semicircles. So arc JML or arc JKL both measure 180 degrees. Okay, so you've got arcs, and do not forget those arc symbols. All right, now remember that. Okay, remember that. What happened to my little words there? Okay, so remember that the measure of angle ARG, remember that it's congruent to the measure of the arc. Okay, so the measure of ARG, so angle ARG is this angle right here. So that means the measure of this arc right here is also 50 degrees. So if AB is your diameter, that means the measure of angle GRB, so GRB. So think about this, okay? If this is your diameter, then that means from here around to here is 180 degrees. Well, if this piece is 50, then you have 180 minus 50, which is 130. So that means this angle is 130 degrees. So angle GRB is 130 degrees. So what's the measure of arc GB? Well, if this angle is 130, then this arc is also 130 degrees. So what's the measure of arc GSB? Okay, so G, it tells you where to start. S tells you which direction to go, and B tells you where to end. So I'm looking at this arc here that goes all the way around. Well, this piece from here to here is 130, right? So if 360 minus 130 gives me 230. So that means all the way around is 230. You could have also looked at it as it's half of the circle plus this piece here. So I could have also said 180, half the circle, plus that 50-degree angle, which would also give you 230. So either way, however you saw it, is okay. Okay, and then the next thing is, what's the measure of arc BSA? BSA. So since I start at a diameter and I end at the diameter, that's a semicircle, so it's 180 degrees. All right, so find the measure of arc TB. So I see arc TB is this arc right here. So let's go right here. So arc TB. Well, if this angle is 50, then I know this one's 50 because remember they're vertical. And if that one's 50, then this arc is also 50. So the measure of arc TB is 50 degrees. Now, AB is a diameter. So if AB is a diameter, we need to find X. So let's go. If AB is the diameter, that means from A around to B is 180. So that means this is 50 degrees, that's given. So this is 50 degrees plus this angle here plus this angle here. All three angles add up to 180. So that means 50 degrees plus 3x plus 30 plus 6x plus 10 equals 180. So I'm going to add my like terms. I got 3x plus 6x, which is 9x. Now I'm going to add 50 and 30, which is 80. 80 plus 10 is 90. So 9x plus 90 equals 180. Subtract 90. Now I have 9x equals 90. Divide by 9. Cancels. And I find out that x is 10. So if x is 10, I can go over here and plug it in. 3 times 10 plus 30. So that's 30 plus 30. So that's 60 degrees. This would be 6 times 10 plus 10. So that's 60 plus 10. So this one is 70 degrees. So the measure of arc GA, so the arc GA is this arc here is 50 because it's the same as the central angle. The measure of arc GS would be this piece here, which is 60 degrees. And then the measure of arc BSA, that's major. So BSA, which so happens to be half the circle, so that is 180 degrees. All right, now there are some rules with chords. Okay, so a chord is a segment with endpoints on the circle. So we learned that the other day. So if you'll notice, M is an endpoint and A is an endpoint. Therefore, MA is a chord. Okay, here's another. The rest of these are just theorems. There's not a whole lot to do. We're going to do stuff with them in class. We're just learning what they're talking about now. All right, in a circle, okay, if you have two chords that are congruent, then you have two arcs that are congruent. So for example, I've got this chord and this chord, and we will call this P, A, H, E. So if PA, so if segment PA is congruent to segment HE, so if PA is congruent to HE, then arc PA is congruent to arc HE. So if these two chords are equal, then their intersecting or intercepting arcs are also going to be congruent. And that's every time. Okay? Okay, now this one says if you have a diameter that is perpendicular, so I have my diameter here. And if it's perpendicular to a chord, then it cuts the chord in half and the arc. So now I have two equal pieces. Okay, so if PE, so if my diameter is perpendicular to my chord, then segment HS is congruent to segment SA, and arc HE is congruent to arc EA. All right, and here's our last one. In a circle, two chords are congruent if they are equidistant from the center. So remember, equidistant means they're the same distance. So if PA is congruent to MH, so if this chord is congruent to this chord, so let's go, if this chord right here is congruent to this chord right here, then this chord and this chord are also congruent. Okay, so if they're equidistant from the center, they're congruent, and if they're congruent, they're equidistant. So it's the same thing going forward and backward. Okay, all right, so I will see you guys in class next time. Have a great day.